So we're gonna teach you some methods first, and then I'll show you examples, and you will see it totally makes sense. Case 1. First, let's try vertical slicing. Vertical slicing. Vertical slicing will have area will be found. Area between graph will be found as the integral from a to b. We did it before. F of x. But now we're going to add something more. Check this graph. I was hiding it from you. Here's the graph. Vertical slicing means, remember we're approximating areas with rectangles, and we just learned different approximation, but let's go back to rectangles, left point, midpoint, right point. So when it was below the graph, it was like so, and we were approximating with rectangles. Well, now, why not to do the same thing with two graphs? Just put lots of rectangles, and now the problem is that you will have to figure out where the rectangle touches the function at the top and touches the other function at the bottom. So instead of f of x dx, we will have f of x minus g of x dx. Difference gives you the area, top minus the bottom. And it should be positive. Areas from now on will be all positive, and I will mention the difference from before a bit later. And what is happening here, we are running from x equals a to x equals b. That is important. Next way will be a bit different. The idea is vertical slicing. We are moving vertically from top to bottom, from top to bottom, from top to bottom. Top minus, let me put in red, bottom. Top minus the bottom. Let me put it again here. Top minus bottom. And this gives you the area between graphs now. Now we're going to have one more way of slicing. Skip some space, because I want to make more notes later. We're going to call it case 2. Case 2. That will be horizontal slicing. Horizontal slicing. Horizontal slicing is needed for this reason. We're still going to have a, and we're still going to have integral. But now, check the difference. Very interesting. What is the difference between those two graphs you see? What do you think? Like visually, what do you think? How would you explain to another person? What's the difference between those two areas and graphs? Look at the blue function f of x. In the first case, f of x is at the top, and that's why I wrote this phrase, top. Where is it on the in the second case? It's on the right. So we cannot now use the same terminology, top minus the bottom. We will be using what? Yes. Right minus left. And that's what it's called horizontal slicing. We're gonna go from right to left, from right to left, from right to left. That means the rectangles we're building will look like so. They will be just lying down. They will be horizontal rectangles, and they will be approximating both. They will be approximating this area from right function to left function. So we're still going to have f minus g. But this time, not only the big difference is over here, the integral instead of from a to b on x-axis, it's going to be from c to d, where it's y equals c and y equals d, from smaller to big one. Then y equals f of x is not used here. We're using x equals f of y. So it's going to be f of y on the right minus f of x on the left. No, g. And not x. G of y on the left. And the integral will be dy. So let's put those in the boxes. The area is also positive. We have case 2 in terms of y, case 1 in terms of x. Top minus the bottom for case 1, right minus left for case 2. Right minus left. It always goes bigger minus smaller, so you don't have to actually remember if it's top minus bottom, right minus left. But visually, that is the case. And the big difference is, for the first case, we are working on AB, that is x-axis. For the second case, we're working on CD, y-axis. And everything should match. Integral from C to D, dy, f of y, g of y, dy. Integral from A to B, f of x, d of x, dx. Variables should match. And that's why we tell you should change variables when you do your substitution. Or at least remember that variables should match to make sense. A, which is area between graphs, is always positive, since now we follow this rule, bigger minus smaller. Before we taught you, if the area is below x-axis, then it's actually negative. Yeah, we kind of made this up. In general, I will explain you why it was negative right now. But now it's always positive. It's area. It's a physical object, cubic kilometer square. So that is a physical object. I can see I have an animation here. This is what horizontal slicing looks like. From the right to left, from right to left. Function is on the right, function is on the left. More, let me show you this one. We will be building some cool 3D functions, 3D object with this. This one, you see, it's top minus the bottom, or right to left. There will be some cases which are interesting. When you project those cases to 3D, you get some cool objects, and when you spin, you'll get cool objects. And look at this. Area between two graphs with fixed point is increasing or decreasing. So point, the areas keep changing, and you can see, maybe you can see the number is huge, then it shrinks. So it's always positive, and it's going to be the area between graphs. That's the whole idea of this chapter. Now, going back. Now I will show you some interesting idea. Example 1. Something you've seen before. What is the idea between this graph, which you've seen before? Let me show you. It looks like this. Say it's a semicircle from A to B on x-axis. And this is y equals f of x. And we ask you to find the area below. Let's do the area between, the area below y equals f of x. Now, so you remember from calculus 1, the area below y equals f of x is what? By definition. Integral from what to what? A to b and f of x dx, exactly. The definition we gave you, one of the applications of the integral, outside of it being smart summation, accumulative sums, it's also area below the graph. It's just one of the applications. Area below the graph. Yeah, we lied to you. We don't do area below the graph. We do area between graphs all the time. Somehow just in this book, they're introducing it slowly. What is the area between the graphs in this case? Minus, I heard you saying, 0, but it's kind of not 0. It's a function called y equals 0. It's the area between two graphs. It's a function minus function dx, and this area is always positive. So when we told you, when the area is below the x-axis, it's negative. It's not negative because it's below. It's negative because it's going to be 0 minus the function g of x. And that's why it was minus g of x. Make sense? So now we know that actually it was not area below the graph. It was area between graphs. And this is a more general case, which I like more. And I like to talk about more. So again, this is the function y equals 0. Y equals f of x minus y equals 0. Top minus bottom. Like so. Top minus bottom. This is area between two graphs. Let me maybe write it down. area between two graphs, which is y equals f of x and y equals 0 from A to B. What do you think about this? Does it make sense? Okay, now those are pictures from the animation I just showed you. Just wanted to show you that it's from top to bottom, but sometimes you will ask me why it's not from right to left. It is. Some cases are both horizontal and vertical slicing, and then it's going to be up to you to decide which one is easier to use. But as you can see, this one is just projection of some 3D object on the floor. These cases we're going to cover in Calculus 3. What happens when you have a fancy shape and the shadow of the shape, which we're going to call projection on 2D plane, is this shape. And this is why this specific topic right now is crucial for you to pass Calculus 3 class, because we'll be making areas so fast and so much in order to build 3D objects, 4D objects, 5D objects. So we need to be very good in 2D before. Finally, let's do some homework problems, the one that's going to explain you everything pretty well. Find the area bounded by. Find the area. And now, bounded by, a very nice notation I found in America, bounded by. My favorite one is BDD. BDD. It's such a popular phrase in applications, especially for engineering and physics major, that BDD is just very convenient. Bounded by. So from now on, I'll be writing BDD. And then I have y equals 5x minus x squared. Y equals 2x. And this is why I send you the announcement saying, watch the video I made about common functions. We expect you to know graphs of common functions. Lines, parabolas, concave up, concave down, cubic functions, sine and cosine. Kind of basic stuff, not too scary. But you should review it if you don't remember. Let me write you down steps. I know that somehow my students always told me it's nice to know what steps to follow. You don't have to follow them. So it's not like it's required, but it's nice to be, I like having some structure. Step 1, sketch the graph. Either using a graphing calculator or old-fashioned way, which I like more, by hand. Sketch the graph. It doesn't have to be precise, but when you do sketch it, sign all functions and points. Sign functions and points. Let me know if you don't like my handwriting. Functions and points. You should sign it because in the future you'll forget which one is which. Color coding also helps. It's what I do, but you don't have to. But when you have 5 functions and you forgot to sign them, when you finish, you'll get lost. You will see that. So I definitely saying that all the time. Don't forget to sign. I do also forget to sign functions, so you should remind me when I do. Step 2. Find points of intersections. Find points of intersections. So let's do that and then proceed. Let's sketch the graph. Y-axis and x-axis. 0. Now we want to sketch those 2 functions. My favorite way to organize the information is actually to number them. Function number 1, function number 2. You don't have to do it either, but it's just my convenient way to remember. The first function is what? What's the name of that function? Parabola, exactly. It's a quadratic function. It's ax squared plus bx plus c equals to 0. And then a shows you if it's concave up, which is smiling, or concave down, which is grumpy. So smiling versus grumpy. That depends on a. And the a we have is minus, so it's going to be grumpy. It's concave down. So a is negative for our case. Now, if you remember from Calculus 1, we taught you shifts and stretching called transformations of graphs. Yeah, I mean, 2 people just said yes, other people like no idea, which is fine. That is okay. In general, you should have just some kind of intuition what happened. This one is not y equals x squared, which is a perfect looking parabola from 0. So it has a shift. To find a shift, you can find a vertex. Vertex will give you line of symmetry, blah, blah, blah. In general, you can also just know how to sketch it. Check the 0 point. If you plug 0, 0, it gives you 0. So it definitely goes through 0. Then you can find the vertex minus b over 2a if you want. Vertex x, the x location of the vertex is minus b over 2a. So it's minus 5 over minus 2. So it's positive 2.5. Right? So we're going to go here. This is my vertex, and it's grumpy because it's concave down. Something like that. So to be honest, lots of this information will not be needed for this problem. That's why I say sketch the graph. Sketch the graph. You don't have to have a vertex most of the time. You just need to know how it looks like. Is it on the top or at the bottom? And some points of intersections will be important. How about the second graph? What's the name of that? That's a line, mx plus b, right? It's a linear. So the perfect line, y equals x. That is the perfect one that, okay, that was not good. Like so. That divides your system of coordinates exactly diagonally, blah, blah, blah. This one is times 2, so it grows faster. It grows twice faster. When you put x equals 1, y is twice more. When you put x equals 2, y is twice more. So it's a stretch. It means it goes faster, and basically it will be like this. So you see, I did not sign anything, and that's exactly what I told you. You're not supposed to forget to sign. I'm color coding, but if you don't, you better sign everything. 5x minus x squared, and then green one is y equals 2x. We are looking for the area between those two graphs. It says find the area bounded by two functions. Here they are. And now it's up to you to choose the case. First case or second case. And I'll show you both. Sometimes you can only do one, sometimes you can do two. So the first case, actually we did not find points of intersection. So let's do that first. Step 2, find points of intersection. So we have points A and B, and if we choose case 2, we will have to find C and D. That's you. To find points of intersection, you go back to your system of equations and solve it. That's what you do. You solve the system of equation, using any method you know. But in general, if left-hand sides are equal and right-hand sides are equal to 5x minus x squared equals to 2x. Makes sense? Y equals and y equals, so make right-hand sides to be equal to each other. Recommendation, move everything to the left-hand side. It's going to be minus x squared. 5x minus 2x is 3x equals to 0. Factor out x. This is quadratic equation, so you can use quadratic formula, but since the isolated constant is missing, just factor it out. Let's do x. It's going to be minus x plus 3 equals to 0. And you have two roots. X is 0, x is 3. That's exactly the points we're looking for, so put it in the box. We found x points. If needed, find y points. Also, you should check it if it makes sense on the graph. If you got x equals minus 17, it doesn't really look like that. So you know, so minus 17 will be over here. Then you know you messed up. So you should check your own answer you're looking on the graph. It looks correct. It's from 0 to 3. So yeah, it looks good. Not too bad. This actually should be past the vertex, I just realized. But whatever. That's why I call it a sketch. You don't have to be good at this. Just approximate. Some people, they realize they don't need the graph. If they know which one is at the top and which one is at the bottom, they're good to go. Step 3. Choose the case. Choose the case. And we have two cases, top minus the bottom case, and then right minus left. Right minus left. Vertical versus horizontal slicing. And you should choose based on how functions are located. This one can be used both. Check it out. The purple function is at the top, that's quadratic function. And the green one, which is linear, is at the bottom. So we can use the first case, which will be top minus the bottom. But at the same time, the green function is on the right, and the purple function is on the left. So technically speaking, we can use the second case as well. It will be green minus purple, and they switch the sides then. So we can do both, and then the answer should be the same because it's area. Area is a physical object. It should be the same. The answer should be the same. So how do you choose? Choose whatever is easier for your personal case. Since all functions are given as y equals blah, 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 y equals blah, 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 why would you choose case 2? Case 2 requires you to rewrite functions as x equals blah, blah, blah. So you will have to solve for x if you choose case 2. Can you solve for x over here? No. So that gives you a good hint that we should use case 1. So, case 1. A equals integral. And now you can help me to build it. Stare at the graph. We have all the information at the graph over here. A equals integral from what to what? 0 to 3. And then what is a top function? Function that is visually on the top. 5x minus x squared minus, and what the function at the bottom? 2x. Boom! You finish the problem, you get full credit. From 0 to 3, the function at the top, I will put it in the colors. 5x minus x squared, this is the one at the top. So it was y equals at the top. Minus the function at the bottom, which was in green color. Y equals, and we just write down 2x. This one is at the bottom. And then we have dx. Integral from 0 to 3. That is location on the x-axis. And you have to check if you messed up or not. Always check that. What if you messed up? So let's check. Integral should make sense. This integral should be in terms of x, dx, from x to x. So let's check that. All variables are in terms of x. That is correct. Go away. Go away. Okay. All variables are in terms of x. Correct. It has dx. Correct. And x is from 0 to 3. Correct. So if you have some y included there, you messed up. You have to convert something into different shape. This is already area. So we just learned how to build area between graphs. This is it. This is how it looks like. And then you integrate. And you will see we're not going to give you hard integrals to integrate in this chapter because we want you to learn how to build the integral first. How to integrate this? Who can tell me very fast? Should we simplify first or just move on? Now let's simplify. It's integral from 0 to 3 what? 3x minus x squared. Amazing. And then you integrate and it becomes what? 3, yes, I can hear you. Minus 1/3 x, yeah, x cubed. Exactly. Good job. A bar, so remember, area should not be a function. We're looking for a specific answer in square meters, square feet, whatever you name it. So plug your numbers, top minus the bottom. We're plugging, I will skip that, and you will get 9/2. 9 over 2, that's the final answer. It better be positive. If it is negative, you messed up. Usually, there are several ways to mess up. Of course, calculations. But I'll make a note for you to know on a test or in your homework. Bless you. If area end up to be negative, then go back and check your order or signs. Go back and find a mistake. And find a mistake. Maybe you messed up top minus the bottom. Then just put a negative sign in front of the integral, you're fine. Or calculations. What do you think? Again, reminding you the shape. Let me put a nice shape here. This shape, this is how the sketch looks like. Parabola, and the line, the shape of this area was like so. We found that top minus the bottom. Top was quadratic function, here it is, minus the bottom, and the bottom was a line, and the area ended up to be 4.59 over 2. So let me write it down over here. It's too small. 9 over 2. Area equals 9 over 2. What do you think about that? Doable? Yeah, the first chapter is pretty pleasant. I think usually students enjoy the first chapter. Area between graphs, and it goes so far. You have no idea how far this chapter goes into calculus 3 and other stuff. In multidimensional theory, it's pretty important. Example 3. Let's do the case 2, and that's how you can start doing your homework and be confident with this. Find the area bounded by. Find the area bounded BDD by. See, bounded BDD only works in English, so I never seen it before coming here. 9x squared, 9y squared, and then 2 plus 7y squared. You already see that functions are written in terms of y. X equals blah, blah, blah. X equals blah, blah, blah. So, oh, I actually did not want to do that, but it's fine. So that means it's a hint. For you, it's probably going to be case 2. In general, we might not give you this nice looking formula. And if you still have space left after bounded by, we might give you 9y squared minus x equals 0 and x minus 2 equals 7y squared. And it's up to you to decide what to do. As you can see, writing it down in terms of y equals and y equals will be hard. It will include square roots, and we don't like that. It's possible, but it's hard. And that's why we have x equals and x equals situation. We chose case 2 because we want to do it faster. So as a scientist, you have methods in your hands, and why not to choose the one that is easier to do? Sketch the graph. Step 1. The thing is, I don't really know really well what is x equals 9y squared. But for you to know, you can just tilt your head to the right, and then it will be whatever you had before in x and y notation when you had functions y equals 9x squared. So you can see it is a quadratic function. So you imagine the parabola. This parabola has 9 in front of the highest power variable, so it's concave up. But then you tilt your head to the right. It will be smiling just to the right, not up. So it will look like so. It also goes through 0, 0. When you plug 0 into y, x becomes 0. And it is a vertex. So it's a smiling parabola, but to the right. So you tilt your head. That's how it looks like. Your coordinates actually can be tilted any way you like. In upper level classes, we will teach you to do that. Don't forget to sign it. This is x equals 9y squared. And the other one is also a parabola. And it's also concave up. So it's also smiling, but it has a shift. So everything shifted by 2 units to the left or to the right. Remember the shift topic in calculus 1? It's a horizontal shift. When we're adding 2, x will be always 2 units more than y. So it's shift to the right in this case. So everything is bigger by 2, and also times 7 makes it a bit thinner or stretched. That's a stretch. So it looks like something, let me see, like so. It's also a parabola. It's x equals 2 plus 7y squared. Our job is to know minimum information, points of intersection, and who is on the right and who is on the left. Who is right? You know, that's what the job is. So you don't have to be precise, and you don't have to be beautiful with those graphs. You just need to visually know which one is on the right, which one is on the left. Points and intersections can be found without the graph. So let's see. We have the graph. Sketch. Check mark. 2. Points of intersections, POI. Not a very good abbreviation because we have points of inflection in calculus 1, but whatever, just to figure out. Points of intersection. It's not very reserved name anyway, so it's fine. We need points of intersection not on x and y anymore because we're building, so let me skip some step and make a point here. We're choosing case 2. Why? Because we have a situation of x equals blah, 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 and x equals blah, blah, blah. So why not to choose case 2, where exactly the integral looks like a equals integral from c to d, x equals blah, 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 minus x equals blah, 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 dy. Do you see what I mean? So it would be function of y minus function of y. I don't want to solve for y to make case 1. And that's where case 2 gets handy. So we need points of intersection C and D now. We need to know where the area starts on the height C and when the area ends on the height D. We're looking for this area. And now the scanning, and the scanning I mean how we're slicing it, becomes horizontal. We're imagining those horizontal rectangles over here. So where do they start and where do they end? From C to D, they're lying down. And we're going from right to left, from right to left, from right to left, like so. So let's find C and D. Points of intersections are coming from the system of equations. X equals 9y squared and x equals 2 plus 7y squared. Left-hand sides are equal, so right-hand sides are equal to 9y squared equals 2 plus 7y squared. It's a quadratic equation, solve for y the way you know. Simplify, in this case, it will be 2y squared equals 2, actually, or you can move everything to the left, why not? Let's move everything to the left. Factor out 2, and you will have y squared minus 1 equals to 0. Solve, so 2 cannot be 0. Then the only case this product is 0 is when y squared equals to 1. What is the answer? Plus or minus 1. Anyone who just forgot minus 1, some panda is crying somewhere in the world. Well, we say, don't forget minus 1, you make some panda cry. Plus or minus 1. Here it is. And it should make sense from the graph. It is symmetrical. Look at that. The graph actually is pretty obviously symmetrical. It's y equals minus 1 and y equals plus 1. That is your C and D. What do you think about this? Do you need my explanation on this? So interesting, we're integrating pre-calculus class into this whole process. So we're doing horizontal slicing, right minus left. Right minus left, and all functions are written in terms of y, which we already have. Now you can read me the answer. A equals integral from what to what? Negative 1 and 1, exactly, from minus 1 to 1. What is the function on the right, visually? 2 plus 7y squared, because this 2 made a shift to the right. So it's a pink one, 2 plus, read me again, 2 plus 7y squared. This one is on the right. And then what is the function on the left? 9y squared, exactly, let's put it in green, minus 9y squared. This one is on the left. So instead of top minus the bottom, we're doing right minus left. dy, let's check that we are correct. The function, the integral should have functions of y inside. We have y, then it should have dy, and it should have y on the limits of integration. Now it means we did not make a mistake. Does that make sense? Everything should match. Only in calculus 3 we're going to teach you integrals with different variables. It will have integral of y squared x cubed minus z square root, and dx dy, or dx dz, and then it will be triple integrals dz. So in calculus 3 we're going to do this. Until we got there, you should not have to end up with integral with several variables in it. Make sense? Because that's called multivariable calculus. So you should check and it should make sense. Again, it's a physical object. So if you have integral in terms of y dy and then from x to x, you mix up units. So it should match. -1 and 1 are y's. Does it make sense? What do you think? Okay, good. Many people said. My dancing teacher, she likes to say, smile and nod. Smile and nod. It's like, yes. So let's do it. Let's simplify. It will be integral -1 to 1 to minus 2y squared dy. Integrate that. Who wants to integrate for me? What is going to be? 2y minus over 3y cubed bar from -1 to 1. You don't have to put parentheses, by the way, but you can if you want to. Plug the top. 2 minus, like you said, 2/3. That was nice. Don't forget minus because of the formula. Plug the bottom carefully. Put parentheses everywhere. Some of you forget to put parentheses, and that then makes typos on the exam and homework. So if I have 2 and then plug -1, put those parentheses. Don't be lazy. Minus 2/3. -1 cube is important because -1 cube is -1. Again, parentheses are good. They do save you from mistakes. So, put them everywhere, just in case. I don't know. That is definitely overdoing it. But at least you will not make a mistake on a test. So, I can see you don't put enough parentheses, and that screws up some negative signs. -1 cube is -1. Minus and minus gives you plus, blah, blah, blah. You better have positive area. If it's not positive, you messed up. Go back and check everything. So the sketch is, let me show you what we did. We had two smiling but tilted to the right. Again, if you tilt your head, that is a normal parabola that smiles up. And we were asked to find this area. So we found where this object, this area starts from -1 to 1. And then we scanned it from right to left, from right to left, from right to left. In general, this kind of way of finding areas is basically recreating CAT scan. CAT scan is, for example, when you put your hand, if you think you broke your hand, the doctors will put it in a machine, right? And it will perform a CAT scan. So how does it do it? It actually does this kind of idea, which is, it first scans your hand, for example, from right to left, right to right, right to left. That is integral from function on the right to function on the left, right? And then it scans it top to bottom, or in this case, bottom from -1 to 1 to top. So CAT scan is something like this. It does a box. Its integral is from -1 to 1, from -1 to 1, from -1 to 1, and that is a little bit too much of the area. And then it scans from right to left, right to left, right to left, from function to function, from function to function. And that makes a net. And this net gives you a scan of your hand or a leaf if you put it. So it's exactly what this integration is doing. Finally, last small example for you to figure out at home. Very interesting case. What example is that? Example 4. Check it out. This topic becomes pretty creative because you will have to be creative at home. So find the area bounded by. Bounded by. Y equals 2 over x. Y equals 8x. Y equals 1/2 x. You see, the functions are actually pretty easy to solve for x and y. So in this case, it's not obvious which case is going to be better. If you need case 1, it's in front of you. If you need case 2, then just solve for x everywhere, and it's not going to be very hard. If you sketch the graph, it will look like so. Let's do something you know for sure. What is y equals 8x? That's the second one. That's a line that looks up, right? Like so. Actually, you don't have to always sign y equals 8x. Some people actually numerate it. So it's function number 2. That's what I wanted to point out. Sometimes there's so many of them, there's no space to write it down. So they numerate it. What is y equals 1/2 x? Let's also align the third one. It's also a line, but it's very low. Every time x is growing, y is twice less. So it's kind of low, increasing. It has a small slope. Slope is 1/2. Finally, who remembers the function 2 over x? What the heck is that? It has vertical asymptote. Actually, 2. Oh, good job. 1 vertical, 1 horizontal. Exactly. And it looks like so. Oh, it actually has more than 1. Let's see. 2 over x. Something like this. I should make it fatter. It also is located on other quadrants, so we're going to only look for this first quadrant for it. This is the area we created. See, it looks like a triangle, but it's not. It actually has a tilted side. This is the area. So how would you calculate this area? Okay, I forgot to number it. This is number 1. See, instead of writing down the functions, I numbered them. So the question is, are the functions at the top and the bottom, or the functions on the right and on the left? Kind of both at the same time. So the guess is to see carefully what to do. From one point of view, number 2 is on the top. Number 1 is at the top. And blue is always at the bottom. From another point of view, number 1 is on the right. And blue, number 3, is on the right. Why? Red one is always on the left. So actually 2 cases will work. But for both cases, you will have to do what? Guess. What do you think? Because we always have 2 functions on the top or 2 functions on the right. So how would we deal with that? Make a guess. Split. Someone says split, divide, break. Break into parts. Break it the way it's easier to see and work with. If we choose case 1, and actually 2 cases will work. Case 1. Then break it in this way. Do I have other colors? Let's do purple. If you break it like so, check it out what's happening. You will find this point that's called C. So A, C, B. And the first integral will be area number 1, and the second integral will be area number 2. The first integral, let's write it down. So the total A will be A1 plus A2. Actually, let's not use number 1 and number 2 in a circle because I already used it for functions. So A1 and A2. We will have 2 areas. Total area is sum of those 2 sub-areas. We call them sub-areas. And it will be integral. So we will have 2 integrals, right? You can actually tell me what the integration is going to be. The first integral is the first triangle. This time it's actually a triangle. The first triangle from A to C. What is A? Guess. 0, right? You can see it's 0. What is C? C, you have to find it by solving blah, blah, blah. Or you actually find what kind of intersection do we need. C is intersection of 2 and 1. This one. So if you solve this system of equation, you will get 1/2. I will just let you know that it is 1/2. So it's from 0 to 1/2. Now you put function that is on the top. What is function at the top? Number 2. Which one is that? 8x. Exactly. Let me do it like so. 8x. That's the function at the top. Minus. What's the function at the bottom? That's number 3. Blue. It's the floor one. 1/2 x dx, that is my first area, plus the second area will be from what to what? From 1/2 to B. B is point of intersection between 1 and 3. So you will have to solve that, and I can tell you that it is 2. So we have 0, 1/2, and 2. So till 2. What's the function on the top for the second area? 2 over x, it's in green. It's visual on the top. 2 over x minus, and the floor is the same. 1/2 x dx. These integrals are pretty simple to integrate. 2 over x gives you a logarithmic function, blah, blah, blah. And you get the final area, and it better be positive. This is going to be final answer. So as you can see, it becomes pretty creative. It becomes pretty creative. So in your homework, if you're stuck, post your questions in the forum and just don't be frustrated. See it as a creative, cool homework.